Hi, so I'll give you some help with probability. We'll start with some non-calculator work. Let's consider a binomial. Now, we're looking for something that can happen, that it can't happen. It's got a probability of success, a probability of failure. That would be binomial if the probabilities remain constant. So this here means we have a distribution happening binomially. Maybe we can do this with 3 attempts, and then the probability of a success is, let's say, I'm going to make it a quarter because a half you might get a bit confused a bit later. So make it a quarter. How would I do this on the calculator? Well, sorry, not on the calculator menu 55A. You can do that pretty straightforwardly. But if I was to ask for, say, 2 wins, or choosing 2, that would be 3 choose 2 times the success to the probability of how many times I want it. And then remember, this is Q, which is always 1 minus a quarter. 3 choose 2, 3 choose 2 is 3. 3 choose 0 is 1. 3 choose 1 is 3. 3 choose 2 is 3. 3 choose 3 is 1. Anything choosing itself is 1. Anything choosing 0 is 1. Anything choosing 1 or 1 less than itself is itself. Confused? Remember, the square happens with both. 3 times 1 times 3 is 9. 16 times 4 is 64. Now, if I was to ask for the expectation, this is equal to NP, but you're looking for, what you're looking for? You're looking for the word large, big, or you can assume independence. But this is independence. I probably spelled that wrong. This is only for binom, this formula. EX equals NP. So in the case we had before, if we said n was 3 and the probability of success was a quarter, that would be 3 quarters. If I wanted the standard deviation, remember the EX is the expectation, standard deviation. Well, the standard deviation is equal to the square root of MPQ, where Q is equal to 1 minus P. So we could write that as NP 1 minus P. So in our case, the standard deviation of it would be N was 3, P was a quarter, and Q was 3 quarters, which was equal to 9 over the square root of 9 over 16, which we can write as 3 over 4. But what if it's not a binomial? What if you've got other things and treat, because you can either have binomial, that's always the first, or we could have conditional probability. Now if we've got conditional probability, we'd use tree diagrams or Venn diagrams or two-way tables. I really like two-way tables, also called contingency tables. So I'll put that in brackets. Now, how do I know not to do a tree diagram and do a two-way table? Well, let's have a look at a two-way table. I'm just doing this really quickly. I missed out. Event A, then this is the event A does not happen, and this is a total. And this is the event B, and the event B does not happen, and then we have the total there. We're told certain percentages, like you said. Oh, the fact that A happens is 30%. The event that B happens is 60%, say, and from this you can you're told that from this you would need one more bit of information. So let's say that neither events happen is 20%. Okay, I'll put 20% in. Yeah, that should work. So we now need to fill in everything else. So we know that that must sum to 100%. That's 40%. That must sum to 70%. So that must be 50%. So that must be 10%. And this final one must be 20%. And you see that they all work nicely. Why wouldn't that work on a tree diagram when you're filling it in? Well, let me try and show you. So we got A, not A. Well, we can do that. We can do this. But now, because we've got conditions, we can't do this bit here, because this is not 60%. That is not correct. Actually, if we get that from the calculator, that's from the table. We can get that from the table because that's A and B. In fact, this is how we can check for independence and things like that. So you would have to know that if we choose A, the probability that B occurs is. Okay? So this is not probability of B. The probability of B is equal to PA and B plus, so that's this root and this root. Okay, and that would equal to, in my case, 60%. So how can we use this two-way table to help me? Well, I can do things like, I know that A and B is equal to 10%. I know that the probability that A given B occurs is equal to which is equal to 10 over, because the percentage is going to cancel out, probability of B occurring is 60, which is a sixth, and so on. How do we check independence? We can see that PA and B is equal to PA times PB, and we know that A and B is 10%, whereas probability of A occurring is 30%, and the probability of B occurring is 60%. Well, 10% is not equal to 18%, so not independent. Okay. For the calculator, a lot of this is very similar. You just need to know how the shortcuts work on the calculator.